the next objective I wanted to talk about was the exponents and how those are related to scientific notation, because scientific notation is something that's actually used outside of mathematics. Like biologists and physicists and scientists tend to use that. So I think it's useful. Because I know that math has not many, like when we study mathematics, we don't feel that there are many applications in real life, but this is one that actually does have application in the outside world. When you read an article or science, they will use that. So first we need to know how to express the exponents. Like I said, it's like 2 to the power 2 is 2 times 2. 2 to the power 3 is 2 times 2 times 2, 3 times, right? So if you write it as a big multiplication, you have 2 times 2 times 2 times 2 times 2. So the 2 is actually going to show up 5 times. So basically what it's saying is that 2 to the power 2 times 2 to the power 3 is the exponents added. Yeah, so it's basically 2. So they would say like when you multiply the base, the exponents add up. Is that okay? Like, have I looked at that?
So then you just take the 2 to the power of 2, and then the exponents 2 and 3 get added. So then it's okay, that makes sense.
Because if you get confused, you can always extend it. I think the best way when you are starting these things is actually writing it out. So write out 2 times 2. Instead of writing 2 to the power 2, you write it as 2 times 2. And then instead of writing 2 to the power 3, write 2 times 2 times 2. And then when you see those things together, you're going to see, okay, I'm going to multiply 2 5 times. Because I have 2 terms here and then 3 terms here, so they add up. So in the end, I actually have 2 to the power of 5. Yeah, so the exponents, of course, you can only do this if you're always multiplying 2s, right? If you are doing 2 times 2 to the power of 2 times 6 to the power of 8, something like that, then that messes up. Then don't try doing that. Yeah. So only because it's I'm always multiplying 2s. That's why I can do that. And then the other rule is that another way of writing square root or cubic root is 1 divided by. So that's going to make our lives easier when we try to like multiply terms together. So square root of 2 is 2 to the power of half. Cubic root of 2 is 2 to the power of 1/3. Yeah, so I don't think you will see that often because we also don't like to use square roots much. It's unpleasant. But if it does show up, you know that it's actually to the power of 1/2. And then the third rule is that when the numerator goes to the denominator, the exponent changes sign. Or when the denominator goes to the numerator, the exponent also changes sign. So when we see something like that, what does 2 to the power of -2 means? It's actually 1 divided by 2 to the power of +2. Okay, so with these 3 rules, you can probably do almost all the equations, evaluations that involve exponents or roots. But you have to have your fraction game cool. Yeah, so here maybe it's a time. Can you go back? Can you go to the chalk, the board for a little bit? Just so you to write some fractions. That's it. Like if I have something like this, and then, sorry, I'm actually left-handed, but I use the right hand for the mouse. So now I'm writing with my right hand with the mouse. It's a little strange. Like maybe if I try. It's just as ugly with the left hand. Okay, so how do we do like a fraction times another fraction? Is that you multiply the numerators. So here we have 1 times 3 and divided by the product of the denominators. So that's going to be 3 divided by 10, if that's okay. Yeah. So sometimes what we have is we have things like this. or these end up all being the same fraction. Why? Because 4 is actually 2 times 2, right? So this is what we call like simplification. You have a factor of 2 on the numerator and a factor of 2 on the denominator. So you can cancel these two out, like 2 divided by 2 is 1. And then this 2 is left, so it stays here. So this is actually 1 divided by 2. The same with 5/10, yeah, 5/10, 5, but 10, you know that 10 is 2 times 5. So this is 1 times 5 divided by 2 times 5. So these two get canceled, and this again gives me half. So this is when we say the fractions are the same. I don't know if that's what you saw, Solstice, but this is one of the cases where fractions that look different actually are the same. Nowadays, because all the cell phones have calculators, if I see a number divided by another one, I'll just use a calculator. Yeah, and the calculator will say that's 0.5 for all these numbers. So then it's like, oh, it's 0.5. Okay, they're all 0.5. Okay, that's cool. Yeah, because I don't know, like 122 divided by 244. Yeah, that's actually the same as 0.5. But sometimes if you're not quick with the numbers, you might not be able to tell. And then this will work later in the next sections. When you guys see something like this, for example, you might see t divided by 2t, right? They don't tell you what t is. But this, again, you could cancel these, and then this will also mean it's still 1 divided by 2. Yeah. Is that okay? Are there any questions? Okay, so I don't know if they had an equal sign. An equal sign is different. This is I'm just having just one fraction and its value, right? But if later on you see something like this, they'll have like, hey, you know, this is equal to, I don't know, let's put it this like x divided by 3. Maybe something like that, no?
No,
and then they want you to find x.
The thing that they were doing had like, it was like an equation, but they made it was like -1 over -3, and then it had a divider, and then
oh, nasty kind. Okay, maybe too many, like 1 divided by half.
yeah, but it was like everything had to be a negative.
Oh, okay, wait.
And it was like everything you do on the right side of the equation, you have to do on the left side of the equation.
Yeah.
And then, yeah, and it was like, and it's exactly the same as this thing. And I'm like, no.
Yeah, you have to do it. Like, that's a shortcut. Right? You have like, if you have this guy equals this guy, and then you're trying to show that you draw a line here, you have to draw a line here, you know, you square him up, you got to square him up too. Yeah, whatever you do on the left, because they started the same, you have to do the same thing on the other side. But the negative with a negative, it's also, look, -1 divided by -3. You got to see it as, this is actually -1 times 1, right? This is another way of explaining. And then this is -1 times 3. So then a -1 and a -9 and the numbers, you cancel them out. So this is the same as 1 divided by 3. So that the negative and the negative, they kind of do get canceled out like this. They become a plus. If you have two negatives, then if they are dividing each other or multiplying each other, then it becomes 1 again.
Okay.
But here, sometimes in the future, you have an equation like this. And so what we do is we multiply both sides by y. actually, we multiply both sides by 3y and see what happens. Yeah, you will have 3y times 1, which is 3y, divided by 3. And then you have 3yx divided by y, right? I cannot write the y here, but let me. Up here. I have 3y divided by 3 equals to 3yx divided by y. Is that okay? Did everybody follow? Are we still together? I multiplied this guy here on both sides by 3y. This is multiplication. Yeah. So because the left side and the right side is the same, when you do anything to one side, you got to do it with the other one, to keep the equality. So now I have, hey, but I have a 3 and a 3. So hey, these guys cancel. And then here I had a y, and then I had a y multiplying. So I can cancel. So in the end, what I have is y equals to, oh, that looks like a z, sorry. Y equals to 3x. This is why sometimes in the trick, they'll say, oh, you just cross multiply, when it's an equation. That's the shortcut for getting to this faster. But if it messes you up, do it this way. Do the same multiplication on both sides and then simplify. Like do it in 2 steps instead of 1. Yeah, is that okay? Also remember, I'm always assuming that whatever I'm dividing here is not 0. Division by 0 is a big no-no. So never divide by 0. Yeah, the 0 should never be in the denominator ever.
I always hear that. Can I ask why?
Because it's not really a number. It's like, if you try to, the thing we do is that we never really divide by 0. But if you have any number, let's say you have 2, and you keep dividing by smaller and smaller numbers, this is going to be a huge number. Like this just gets bigger and bigger, the smaller you reduce this. So it means that by the time the denominator becomes 0, this number is actually infinite. It's not a number. Infinity is not a real number, guys. Infinity is not, don't mess up with infinity. A lot of mathematicians studied infinity and then went crazy. Yeah. So it's just like, it's a very big number. It's going to be 10 million, 100 million, 1 billion, 1 trillion. And then eventually it's going to be a number that doesn't have a limit. So you can never divide by nothing. Because something divided by nothing is kind of like everything, kind of like that.
Yeah. No, that makes a lot of sense. That also sounds like a sci-fi plot. Like
no, because imagine like you have nothing. I have so much more than you have, no matter what I have, right? Even if I have just 1 penny, if you have 0, if you're completely broke and you have 0, the fact that I have $1, I have infinitely much more than you do, right? So it's just, it's not a real number. But if you have 5 cents, then I could say, hey, $1, that's like 20 times what you have, right? I think, yeah. So you could still divide, but it is nothing, right? Nothing. Compared to nothing, it's like everything. So that's not a number. So it's an illegal move actually to divide by 0 always. So every time also when you have like a square root of negative numbers, also not a real number, right? That's an imaginary. That's called, I don't want to go into that, it's not algebra anymore. It's called imaginary numbers. Mathematicians have an answer for that, but it's not a real number because any number you multiply by itself is always going to be positive. So you cannot have a square root of, that's also, so later on you will see like domains of functions. For those of you who get there, you'll know that, okay, you cannot be negative. Yeah, cannot divide by 0. It cannot have square root of negative numbers. Those are like 2 basic rules for algebra. because it's impossible. Yeah. Okay, cool. So let's go back to the slides. So that's, now that we see exponents, I would like to go back to see how scientific notation works. So scientific notation, what they do is they get any number and they make sure that it's in this format here. M, a number M, which is always between like the absolute value, the number, don't care about the sign, whether it's positive or negative, but the number there without the sign is always between 1 and 10. And then multiplied by the power of 10. So we can start from small numbers, like, let's go to the next slide. I have some examples. Let's start from the second one, right? Second one, 200. That's like the famous one. I should have put that first. Sorry. 200 is like 2 times 100. So, and 100 is 10 to the power of 2. So on the left column, I have the number written any way I feel like. And then on the right side, that's in scientific notation. And then I don't know if you guys know, but the shortcut to see what's a part, you see how many, if it's a number that's bigger than 1, you see how many zeros you have right behind the number. So the first one is 3 followed by 4 zeros. So it's 3 times 10 to the power of 4. 200 is 2 followed by 2 zeros. So it's 2 times 10 to the power of 2. 0.005, this is divided by powers of 10. So it's going to be 10 to a negative exponent. Is that okay? Like 0.1 is the same as 1 divided by 10. So 0.005, the trick is starting from the dot, how many houses I go until I get to 5, right? So from the dot to get to 5, I have to go 1 left, 2 left, 1 right, 2 right, 3 right. So I went 3 steps to get to 5. So it's 5 times 10 to the power of minus 3. And then again, 0.0007925. So I went 1, 2, 3, 4 houses to the right to get to the 7. So it's actually 7.925 times 10 to the power of 4. Yeah, so what you have on the right hand side is the scientific notation of the number on the left. Yeah, and
will we see this in some equations and things?
I think you'll never see this in mathematics again, but you might see this in physics,
Okay.
chemistry, engineering, biology, you know, because when they like mole, the chemists have this mole thing that's like, I don't know, like a huge number with lots of zeros. So then this is one way to describe very large or very small quantities. Yeah, like nanometer, micrometer, you know, like when we go to micro decimals and stuff, because like the size of a bacteria, then they have to start using this 10 to the power negative something.
So it's not something we'll see in like a lot of problems or anything.
No, we mathematicians, we don't really like to use numbers. Yeah, but in real life, you'll see that. Sometimes you see like that's like a newspaper article or a scientific article. Then they'll say like how far, for example, that they found a planet, I don't know how far from us. Or if you want to say how much money Bill Gates has, you might need to do that, right? Because he has too much money. It has too many zeros. So you can't just expand in zeros. You just start saying he has maybe, I don't know, it's like trillion maybe. So it's like 3 trillion would be 3 times 10 to the power of 9 maybe. I'm not even sure. Yeah, I think 9.
Okay.
No, more. I don't know. He has so much money. I'm confused. I have to expand it. A million is 10 to the 6. So billion is 10 to the 9. Trillion would be 10 to the 12. So if someone is a trillionaire, that means he has 1 times 10 to the power of 12 US dollars. So it just becomes too long to type it out, you know, and then that's when you will see this. But it's kind of useful. And then you need to know that when the exponent of the 10 is a negative number, that means it's really, really small.